Thinking about utility can be a little bit tricky, and I don't want to get too far into the weeds about exactly what utility is. Sometimes economists think of utility as how much you like something, how happy it makes you. So you could think of utility in that case as sort of a psychic benefit. On the other hand, it doesn't have to reflect happiness. Utility for some object might just mean how much use you can get out of it. How useful is that object in achieving other things that you want to achieve? The most important thing to remember is, as far as utility is concerned, more is preferred to less. People are better off with more utility than they are with less utility. Now you can have utility for anything. We could have utility for shoes, utility for smartphones, utility for cars. And you can define a utility function, call that u of x, where x represents the good or the service. Specifically, x represents the amount of that good or service. And u of x maps how much you have of that good or service into a utility level. It tells you how well off are you for a certain amount of this item. For this lecture, we're going to assume that x is money, because money is a good that everybody has use for, everybody gets some utility out of. As an example, we could define a utility function that says u of x is equal to the square root of x, or x to the 1/2. Now please keep in mind this is only an example. I'm not saying that every person has a utility function for money that looks like this, but this particular utility function will be useful for this lecture. Now with a utility function that says u of x is equal to the square root of x, what that would mean would be that if the person had, say, $4, their utility level would be 2. If the person had $25, that would give the person a utility level of 5. Now you don't need to worry too much about what exactly 2 means, what exactly 5 means. We don't need to get philosophical about this. All you need to understand is that a utility level of 5 is better than a utility level of 2. To determine somebody's risk preference, we're going to use a thought experiment. Assume that we have a gambler, and we're going to offer her 2 choices. One choice is to take a lottery ticket that entitles her to play a lottery 1 time. For simplicity, we're going to assume that that lottery ticket will allow her to play the coin toss lottery, where I flip a coin, and if it comes up heads, she earns $900. If it comes up tails, she earns $0. This lottery ticket has an expected value equal to $450. The second thing that she could choose would be to take a pile of cash that is equal to the lottery's expected value. So if this lottery ticket, on average, will pay off $450 per play, then we set next to it a pile of cash equal to $450. What we're going to do is find out how much utility she would get from playing the lottery, and we're also going to find out how much utility would she get from just taking the cash with no risk associated with it. And she will choose whichever of those 2 options gives her more utility. We're going to start by calculating how much utility would she get from the cash, because it's an easier calculation. The utility that our gambler would get from just taking the cash is called her utility of expected value. We call it that because it's the utility that she would receive if she just took the expected value of the lottery with no risk associated with it. She just knew that she would get the expected value for certain. Calculating the utility of expected value is really pretty easy because we know what the expected value of the lottery is, and we also have a utility function that tells us how much utility the gambler would get for any amount of money. So mathematically, the utility of the expected value is u of e of x. And the notation here might look a little bit ugly, but notice that all we're doing is we're plugging in the expected value of the lottery into the gambler's utility function. Now remember that her utility function in this example is u of x is equal to the square root of x. And also remember that the expected value of this lottery is $450. So we can calculate the utility of expected value by saying the utility of expected value must be equal to the square root of the expected value. Since the expected value is 450, that means we're finding the square root of 450, and that gives us a utility level of 21.21. Now again, don't worry too much about what exactly 21.21 means. That is just going to serve as a reference number. That's her utility level for taking the cash. It doesn't really mean anything to us until we compare it to how much utility she would get from playing the lottery. Finding the gambler's utility for the cash was very simple, but how are we going to find out her utility for playing the lottery? For that, we're going to find out what would be her utility for playing this lottery on an average play. So for that calculation, we will first find her utility if she were to win the lottery. Then we'll find her utility if she were to lose the lottery. We're then going to multiply both of those utilities by their probability of occurring. And once we've done that, we sum the products, and that will tell us the amount of utility she would get from the lottery on an average play. We call this utility calculation expected utility. It is the expected utility of the lottery. And notice that expected utility is similar to the expected value, except that with the expected value, we were finding out how much money the gambler would earn on an average play. With expected utility, we're finding out how much utility she would earn on an average play. Mathematically, the expected utility is represented by E of U of X. And again, this might look a little ugly, but notice that all we're doing is finding the utility of each of the possible payoffs, and then we are calculating the expected value of these utilities. Using the coin toss lottery as an example, there is a 50% chance that the gambler would get $900. And so we multiply the square root of 900, that is her utility if she wins $900. We multiply that by 50%, and then she has a 50% chance of getting $0. So here we multiply the square root of 0 by 50%. And you'll find that then if you sum those products, they are equal to 15. Now we can work out what the gambler's preference is. If she plays the lottery, she can expect to receive a utility level of 15 on average. If instead she takes the cash with no risk associated with it, then she gets a utility of 21.21. So clearly this gambler would rather take the cash.